Okay, I kind of planned on this being the hardest chapter that we were going to have to deal with. So, questions on this, I'm not really surprised. A lot of this is review from what you had with Mr. Doyle, but it's just taken in a different way. So, understanding how biology uses the chemistry can get a little confusing. But anyway, I know you think I'm crazy, but the answers for all of these questions are right in the reading. Okay? So if you are stuck, and I understand some of you are, all I did for where are we? Oh, you can see the kind of annotations I made. That's what you call it if you take and make notes on the side, you annotate it. So I annotated some of the questions here, like question set 2, question 1 is listed right there. Autotrophs or producers such as plants, and that actually gives you the answer. All right. You may have to read and reread this section. I know that doesn't sound overly exciting, but realistically, how much TV can you watch? Okay. Or YouTube videos can you watch? You know what I mean? Like, just reread it. On the vocab, I went through, and this is just Reagan's book. She didn't know I was using hers when I did it, so, or what I was doing with her book. But what I did is, there's the word. Here are the 2 pages in the reading where it's mentioned. All right, it was mentioned on page 93, and it was mentioned on page 95. All right, and with that, I just double-checked her answer, and yes. A substrate is a location on an enzyme where the substance fits closely with that enzyme. All right. Understanding the big picture with these things, and going over some of her stuff, and I'm sure some of yours, right? I don't have all of your books to read, but I did have Reagan's, and there's one really, it's like a simple concept for me to understand, but I understand when you're first learning it, it's really complex. Figuring out what is what, and what cells can do what things. So see that section right there, chemical compounds? Focus on that. Understanding what needs to be broken down and what the products are when you break it down, and vice versa. If you take a simple thing and build something with it, all right, that's going to be synthesis, and your body has to do that a lot too, okay? For example, one of the big things that was in at least 4 of the questions there, it showed a picture of a starch. Then there was a lumpy thing underneath it that was supposed to be the enzyme, and then there was 2 smaller parts. Well, since it was labeled as a starch right there, and it's broken down into something, you needed the simple sugars, all right? If it showed you 2 simple sugars, and then it makes 1 large molecule, that's just going this way, so that would be your starch, okay? So if it goes from simple sugars, 2 small simple sugars, to a larger molecule, that would be your starch. If it goes from a large starch to 2 smaller molecules, that would be your simple sugars, okay? You have synthesis, which is putting things together, taking 2 small things and putting them together. And then you have digestion, where you take 1 large thing and you break it into smaller parts, okay? It's not that your body needs only the complex structures or only the simple structures. Your body needs both, right? Like, you can take proteins, like here, from, let's say you went and had a fish fry, or you ordered in a fish fry, because we can't go anywhere now anyway. But you order in a fish fry, and you have fish proteins, okay? Well, those fish proteins cannot make muscles directly for you. Those proteins are broken down into amino acids, the building blocks, and then those proteins can then get synthesized back into proteins that make muscle fibers for you. or those fish proteins can get broken down into amino acids that make enzymes for you to be able to do things, okay? Nucleic acids. Your body can take the nucleic acids from that baked potato that came with your fish fry, break it down into nucleotides, and then fuse those nucleotides back into nucleic acids through synthesis using enzymes to build you back up, okay? The enzyme action is huge on the regions. They want you to understand how it works, all right? An enzyme just makes it possible for your body to do things, okay? The way I look at them, they're a lot like tools, okay? In there, they mention, in the reading, pages 93 and 94, really, really information dense. You're gonna need to read it and reread it, okay? But with those, the way I look at enzymes, they are tools in a toolbox, okay? If you are building a house, you are going to need a wide variety of tools because you use a wide variety of materials, right? You are going to need a hammer. Sometimes you've got to speed it up, so you use an air nailer. Sometimes you're going to have to put screws in, you have to attach the outlets. So you need to screw those in, or you need a drill. All of these things are like individual enzymes that help you do things. When you take 2x4s and bang them together, you are synthesizing something. It's like taking amino acids and fusing them together to make large proteins, okay? When you are taking something apart, say you screwed up. You were making a door jamb, you nailed 2x4s together, and you need to split those apart. You need a different tool. That would be like digestion. You need a different enzyme, okay? If you get out of the optimal pH, meaning the solution gets too acidic or the solution gets too alkaline, the tool no longer works, right? If I take a hammer and I try and use it as a screwdriver, it isn't going to work. If I take a hammer and I get it too hot and I try and use it, it will just bend, okay? That's what that means. You can deform or denature the enzyme, okay? But as you go through that chapter, and I know it's a pain, but really it's only two pages of really dense reading, all right? And read it and reread it so that you understand how this goes, okay? Then if you still have questions, you don't understand how they work, then feel free, message me, and I'll walk you through some more. But I went through on the questions here and found out exactly, where these things were mentioned. Set 2, chemistry, question 4. Starch molecules present in a maple tree are made from materials that originally entered. All right, so what do they make starch from? Well, they don't make anything from enzymes. Enzymes are just the tools. If you're going to make starches... starches entered. Oh, boy, I forgot to underline that word. Entered the tree. If they entered the tree, where was that from? That was from vocab set 2. Told me that they entered in as inorganic compounds, right? Remember, organic compounds contain hydrogen and carbon, and they're larger molecules. The inorganic molecules do not contain that level of carbon or hydrogen, okay? They can have smaller amounts, right? You can have CO2 is inorganic and H2O is inorganic. But the two of those come in together and they make a starch molecule, okay? The plant can take small molecules. If you remember, where was it? The one that you guys hated. I beat it into your head so much. Right there. C6H12O6 plus 6O2 yields 6CO2 plus 6H2O plus ATP, energy, adenosine triphosphate, one of New York State's favorite little abbreviations, ATP. And remember, all that is cellular gas. That's what creates the energy for your cells. Your mitochondria are like your little engines. ATP is like the gas. But the cool part is, in plants, at least, they can make their own fuel. Okay? Now, this one was a problem. I had a couple kids ask me about this question here. All right. A biological process that occurs in both plants and animals is shown below. A plus B in the presence of C makes ATP, energy, plus D plus H2O. It's this equation here. Okay. It's sugar plus oxygen in the presence of enzymes makes carbon dioxide and water. Okay. The big thing, in order to be able to do those, read and reread them. If you still have questions, please feel free to get in touch with me. All right. Cells and cell processes aren't anywhere near as tough. All right. That one I didn't think. If you do, let me know. I'll walk you through that too. Okay. They're big on this, the lock and key understanding. Okay. You have the enzyme. The enzyme, it breaks off and can get reused every time. You have the molecules. If it's building them, it is synthesizing. If it's breaking them down, it's digestion. Okay. They want to know, the lock and key method. How does that work? Why do you need enzymes? They lower the reaction temperatures and they speed up the reaction rates. They have an optimum temperature and an optimum pH at which they work. Understanding which organisms do what, or which organelles do what. Sorry, I'm going to try not to flip that. Which organelles do what, but all of that is listed right on pages 93 and 94. By the time you're done with that, if you reference every question like I had done earlier, back to those 2 pages, okay, just make your reference points, your annotations, and go back and tell you exactly where the things are, okay? That whole section, 93 and 94, will just be a whole collection of numbers and lines taking you back to each one of these annotated questions. But it will help you understand it, and it'll work to get you familiar with the book so that you can find answers more easily. Oh, and this was another just quick one. These graphs have been on the last few regions. I don't know why they love them so much, but it says the graph below shows the effective temperature on the relative action of an enzyme X on a protein. Which change would not affect the relative rate? That is key, knowing what would or would not. Okay? I'm telling you, this thing's a reading test. It is not a science test. But which change would not affect the rate or the relative rate? And the answer should have been 2. An increase in temperature from 70 to 80. The reaction's already dead. It wouldn't matter. You could take it from 70 to 300. It wouldn't matter because the reaction's already dead. Okay? If you were to add cold water when it was at 50, that would bring the temperature down. That would slow it. If you were to remove the protein, if you took the enzyme out when the reaction was here, or take the protein out when it was here, that would kill the whole reaction. If you decrease it from 40 down to 10, what'd you just do to the reaction rate? Okay, so only one of those makes sense, but the key is paying attention to that word right there, not. Okay? Anyway, I hope you all stay safe. If you have any further questions, please just text me, or maybe not text me, but just send it on the Google Classroom thing. Just make sure you read the stuff and watch those videos. That Paul Anderson, he is good. He's fast. You may have to watch it twice, but he is good. All right. Stay healthy. Talk to you soon. Bye.